So hello everyone, in this video we will solve another lead code question, that is word break 2. So we are given a string S and a dictionary of strings which is word dict, and we need to add spaces in string S to construct a sentence where each word of that sentence is a valid word present in the dictionary, and we need to return all such possible sentences, and we can return in any order. So let us see this first example and try to understand what the question is saying. So this is the string that they have given, and this is the word dict, and this is the expected output. So let us see how we can get this output from this string. So this is the string cats and dog. So we need to add spaces in that string such that we can make sentences, and from that sentence each and every word should be present in this word dict dictionary. So how we can generate this output? So given a string, this is the string cats and dog. So one way is that we can add a space here, so it will become cat space sand, and we can add one more space here, so it will become dog. So we will check if cat is present. Yes, cat is present. Is sand present? Yes, sand is present. Is dog present? Yes, dog is also present. So this is one valid sentence, so we will put this in our output. So another way to add space can be, let's say, cat, sand, dog. So one way can also be that we add a space here after cats and we add a space after and. So this will be becoming cats space and space dog. Now we will again check if this cats is present. Yes, cats is present. Is this and present? Yes, and is also present, and dog is also present. So this is one also valid valid sentence which we can make. So we will add that to our answer. So in this case there can be only two possible sentences made, so we will return this output. So now the question is, how will we do it? So looking at the constraints of the question, the constraints are very low, so we can do a brute force backtracking approach. We'll use a brute force backtracking approach in which we will check each and every substring, that if that substring is present in our word dictionary or not. If it is present, we will take it, and we will again check by removing it if we can make a bigger substring that is present in our word dict or not. So let us dry run this what I am saying, and we will understand in more better way. So this is my string cats and dog. So what we'll do, we will first take the substring C. So we will check if this C is present in our word dictionary or not. So C is not present, so we will extend our substring. We will check if CA is present or not. So we will check in this word dictionary if CA is present. So CA is not present, so we will again extend our string. So we will see if CAT is present in our word dictionary or not. So yes, CAT is present, so we will make one word CAT. Now from here we will extend our sentence. We will add space and we will manage them when we will see the code. For now, let us understand the basic thing what we are actually doing. So our next substring will start after T. So we will sorry for that. So next substring will start after T. So we will check with S if this S is present or not. So S is not present, so we will extend our string. If S is present or not, so SA is also not present. We will then check SAN is present or not. So SAN is also not present. We will again extend is SAND is present or not. So yes, SAND is present in our word dictionary, so we will add it to our sentence. Now after that send, we will move our pointer and we will check the next substring. So next substring will start from D. So we will check if D is present or not. So D is not present in our word dictionary. Then we will check if DO is present or not. So DO is also not present. Then we will again extend our substring if DOG dog is present or not. So yes, DOG dog is present in our substring word dictionary. So we will add this to our sentence. So it will be DOG. So one sentence can be cat, sand and dog. But in the output we are also having another sentence cats and dog. So how we can do this? So that's why we will use a backtracking approach where after taking a particular word, making a sentence, we will again backtrack to make a further big string. Is it possible to make or not? So let us see this again. So our string was cats and dog. So in the previous case we have taken this cat. So in the backtracking we will not take this word, we will extend our string. So now string would become cats. So we will see if this cats is present in the dictionary or not. So we will find that yes, cats is present. So we will add this to our word. Then we will start a new substring from A. So we will see if A is present or not. So no, A is not present, AN is not present, A and D is present. So A and D is present in our word dictionary. So we will add that to our sentence. Then again for dog, dog is present. So we will add this to our sentence. And this is also another sentence that we have formed, that is cats and dog. So we have made two sentences. One is cats and dog, another is cat, sand, dog. So these were the two possible outputs that we have generated, and according to the answer, these are the only two outputs possible. So this is the approach that we will going to use. So initially what we will do, we will store this entire dictionary words inside one set, so that it is easier to check if a particular word is present in a dictionary or not. So we will not check in the dictionary, instead we will check in this set. So we can use find function in set, for which we can easily check if a particular word is present in a set or not. So we will first insert all the words in this set. Then we will do the entire backtracking approach. So let us see the code now and understand in more better way. First we will declare a set st, and first we will insert all the words of this word dict into our set. So by this we will insert all the words present in our word dict into our set. Now we will create one vector of string which will store all the possible sentences answer. Then we will write a solve function which will do a backtracking and give us all the possible sentences, and in the end we will return this answer. So let us see this solve function. So first we will put string s, then we will put the set, then we will also put the index from where we are starting. So initially it will be starting from 0, so we will push 0. Then we will add answer, and we will also put this word dict. So we will also maintain one current string which will store a particular word, or which will not actually store a word, it will store a particular sentence. So our sentence will be starting from empty, so we'll be pushing an empty string. So this empty string will contain the entire sentence that we will add to our answer. So let us write this solve function. String s, then we have set of string st, then we have vector of then we have index. So we will iterate with the help of I pointer, so I am declaring I. Then we have vector of string ans, and in the end we have this word dictionary. So what will be the base case? So whenever we complete the string, that means whenever we reach the end of the string, that means if our I is greater than equal to s dot size, that means we reach the end of the string and we have made a particular sentence. So we will add that sentence to our answer. So we'll add this current string to our answer. So we haven't declared this string, so we need to write string current. So this string current is storing the current sentence which is we have declared here. So this string current will store the current sentence, and whenever we reach the end of the string s, we can say that we have created one sentence. So we will add the sentence to our answer, and we will then return back. Otherwise what we are doing, we are checking each and every possible substring. So we will make one j pointer which will start from I and go till the end of this string s. Also we will create another string which will store the current word present, not sentence, a current word. So we have seen a cat is being made, a dog is being made. So this string will contain that particular word, cat, dog, etc. So we will keep on adding this to our string t. So that will be j, s of j. Now we need to check this current string is containing a word. We need to check if this word is present in our dictionary or not. So we will check if st.find of t is not equal to st.end. That means yes, this word is present. If this word is present, we will take this to our sentence and we'll move forward. So moving forward means we are just incrementing, we are just moving our pointer. So what will be the next pointer? Obviously, if we have, let's say this example, if we have made cat, so our next pointer will be starting from s, right? So how will we denote in terms of this I and j pointer? So we have made this string cat with the help of j pointer. So our j would be present at t. So we need to start from s. So what will be this position of this s? It will be j plus 1 obviously. So we'll start our making new word from this j plus 1 index and we will have answer as it is. Another thing is we will add this particular word to our current sentence. So we'll add this t to our sentence. Another thing is we need to add spaces also. So we will add one space here and word dict will remain as it is. So this will be keep on doing and in the end we will be getting all the possible sentences. But one more thing is to notice that if we have made a particular word, added a particular word t into our sentence current, so in the end it will have one empty space. So whenever we are adding a sentence to our answer, we need to pop back the last space that we have created. So before pushing this current sentence to our answer, we need to first pop back, because the last word, so the last string would be this empty space, so we need to pop that. So that's why we are writing this current.popback. So this is the entire code. Let us see what we are doing. So we have added the entire strings present in the word dict or entire word into a set so that it will be easier to check if a particular word is present or not. So we have made a set and inserted all the words present in the word dict. Then we are doing a backtracking. So in this backtracking, if we reach the end of the string, that means we have constructed one particular sentence. Now before adding that sentence, it will contain empty space at the end. So we need to pop that first and then push this current sentence to our answer. Then we will return. Otherwise what we are doing, we are creating a string which will contain a particular word, which will store a particular sentence, it will contain a particular substring. So we will check if this substring is valid word or not. So for that we are finding if this particular substring is present in this set or not. So if it is present, that means it is a valid word. So we are doing a we are moving then forward. Now when this iteration will get over, it will then again backtrack. So we don't need to pop back. When it will pop back, it will automatically add a new particular character to this tree. So it will keep on happening and keep on adding sentences to our answer vector. And in the end, we will get all the possible sentences and we will return that. So let us see if this works on sample test case or not. So yeah, it works fine. Let us try to submit. So yeah, our code got accepted. Hope you learned from this video. Thank you.